All right, this is a walkthrough for Unit 7 bell work number 8 that we did. Most of y'all were here Friday, but for those of you who are absent, I went ahead and recorded this so that I could walk you through it. So we're going to look at this topographic map and answer based on this map. It says, base your answers to the following questions on the topographic map below. Points A, B, C, D, and X are represent locations on the map. Elevations are measured in feet. All right, so let's take a look at what we've got. We have our map. Notice that we have a horizontal distance scale down here, given in miles. We have a compass needle that shows our direction. And then we have several contour lines, some of which are marked, some of them are not. So first of all, what is the elevation of each of the following points? Well, if they're on a contour line and the contour line is actually marked, then it's going to be fairly easy to answer that question. So the elevation of A is 900. And it says up here that elevations are measured in feet. So it's going to be 900 feet. The elevation of B is over here. B, if you wander around far enough, the line is 900. But also, if you go back one, it's 800. And if you go up one and follow it around, it's 1,000. So B is also at 900 feet. Point C is fairly easy because it's on a line that's marked, and it's marked right beside point C. And then point D is also on a line that's marked. It's 1,000 feet. Number 2 asks, what is the contour interval of this map? Because it's not stated, but you have enough information from the map to answer that. Okay? If this line is 900 and I go up to the next line and that line is 1,000, that is a change in elevation of 100 feet. So my contour interval, which is the change in elevation from one line to the next, is 100 feet. Okay, on the back, it asks you to calculate the gradient between points C and D and calculate the gradient between points A and B. Okay, you may not be familiar with this, but gradient is basically a science equivalent to slope. So you're basically calculating the slope of these two lines, okay, or these two hikes, if you want to put it that way, okay? So let me show you what we've got. So I would add this to the back. Gradient is the change in y values, so up and down, and that's going to be your change in elevation. Remember, the triangle stands for the words change in. And then the x values are going to be your horizontal distance. So if we calculate the gradient between C and D, here's what we're going to do. First of all, let's look at where C and D is. It's right here. The change in my y values, D is at 1,000, C is at 1,500. 1,500 minus 1,000 is a change of 500. Okay, so I have a change in elevation of 500 feet. Then I also need to measure the horizontal distance. What I'm going to do to find the horizontal distance is I am actually going to place a little sticky note right there, and I'm going to mark, there's C, and there's D. Then I'm going to peel up my sticky note, and I'm going to put this down on my horizontal distance scale, and I can see that from C to D is a horizontal distance of 2 miles. Okay? So therefore, my gradient is a change of 500 feet. So because it was 1,500 minus 1,000, and then the horizontal distance was 2 miles. So 500 divided by 2 gives me a gradient of 250 feet per mile. Okay, the next gradient is calculated between A and B. So if we look, here's A at an elevation of 900 feet. Here's B at an elevation of 900 feet. So A is at 900, B is at 900. 900 minus 900 is 0. So if I do the whole walk together, my gradient is going to be 0 feet divided by however long this is, which it's about 7.5 miles. Okay. So my gradient is going to be 0 feet of elevation change divided by 7.5 miles. And I'm going to get 0 feet per mile. Now, be careful here because you might look at the gradient and say, oh, okay, so that's a flat walk. Here, it only indicates that I'm starting and ending at the same elevation. If I had taken my walk from A to B and divided it in half and calculated the gradient, then I would have gotten a positive slope here. So I would have gotten some number for a gradient. And from here to the end, if I had taken those numbers and calculated the gradient, I would have gotten a negative slope. Because basically, at A, I walk uphill until I get to about here, and then I walk downhill. Okay? So it can be misleading, but calculating the gradient, you're basically calculating the slope of a line. All right. Next question is, in which direction does Fish Creek flow? Here's Fish Creek. In your book, it reminds you that contour lines that cross a stream valley kind of kink and make V-shaped contour lines. Okay, so there are my V-shapes. And if I make those V's into arrows, they point upstream. So upstream or uphill. So this is uphill. So the water is going to flow downhill, which is in the opposite direction. So the water is going to flow this direction. And it's not perfectly east, but it's really close. So we're just going to call that east. Then we're going to do what is the elevation of point X. Point X, I'm going to have to estimate the elevation of point X. Why? Because it is not on a line. If it was on a line like C or D or A or B, I could tell you exactly what the elevation is. So the only two ways that you can give me an exact elevation is if it's on a line or if it's like this and the elevation is stated out to the side, which it's not in this case, so we have to estimate. All right, so this is 1,000. This has got to be 1,100, 1,200, 1,300, 1,400, 1,500, 1,600. But X is within that circle that represents 1,600. If it was exactly 1,600, the elevation, then it would be on the line. So I know it's not 1,600. I know it's more than 1,600 because it's inside the line. However, I also know that it is less than 1,700 because I do not have a contour line for 1,700. So X, you're just going to have to estimate, and it's going to be something that's more than 1,600 but less than 1,700. In cases like this, a lot of times I just cut it in half and I say approximately 1,650 because that's kind of halfway between the two. Okay? And that little squiggly line means approximately. All right, number 6. Just to prove that you're listening and following along, you're not going to actually see me do any marking on number 6, but let's talk this through. Which cross-section best represents the profile along straight line AB? Okay, here's A, here's B. A starts at 900, B finishes at 900. So the first thing I'm going to do is I'm going to look at my graphs. This one starts and ends at 900. This one starts and ends at 900. This one starts and ends at 900. This one starts and ends at 1600. So I'm going to eliminate number 3 because the elevations at the start and the end are not correct. So I'm going to eliminate 3. Now let's take a closer look at that line. If I start at A and I walk towards B, I'm going to hit this lake and cross this lake. Well, lakes lie in low spots, so I know I'm going to go A, down just a little bit, not much, and then back up to 900. So 900, a little bit of a dip, back to 900. And then I start climbing the hill. 1,000, 1,100, 1,200, 1,300, 400, 500, 600. This is about the high point of my walk. And then the lines get closer together. And I know that lines that are close together are steep. So I need a little dip at the front, gradual uphill, and steep downhill to finish. So which one's got a little dip at the front, gradual uphill, and then a steep finish downhill? And that's going to be number 1. Okay? 7 and 8, again, that's a bell that you guys don't need to pay attention to. Sorry. Which side of Rock Mountain is the steepest? Give me a compass direction. Rock Mountain, if I draw a compass needle right through Rock Mountain's summit, this is north, south, east, and west, my contour lines are closest together right through here. So it's going to be steepest, you could say like north or northeast. North, northeast. And my contour lines are furthest apart if I walk this way. And that's kind of northwest. So that's the answer to the last 2 questions, 7 and 8. All right. That should walk you through, get you to the end. You need to turn this in to me when you get it finished.